Okay, so what we're going to look at today is the last page of your notes, and this is really going to finish up the unit for us as well. So we will be looking at an upcoming test very soon. So this question of the day is looking at what are the two ways that you can induce, and remember induce means to create, produce, that kind of thing, an electrical current. So I want you to go ahead in Edpuzzle and tell me the two ways, number one and number two. I want both. Please do not put IDK. You can go back and look at your previous notes, look at previous videos to come up with this answer in order to get it correct. But what you should have come up with is that by moving a magnet through a coil or by moving a wire coil within a magnet, you are going to be able to produce electrical current. Okay. You had a lab that actually you did this number one with, and then number two, you actually had an activity or a video that showed you how to do that with the gentleman turning the crank and was showing you how the little light bulb turned on and off. So those are the two ways that you can induce an electrical current. Now, what I want us to look at are applications. And once again, you've also watched a video with different applications of electromagnetic induction. Some of you guys had put a motor, and that's not correct. So you want to make sure that you're always listening to things very correctly. If you look down here, this is actually an example of a generator. And when you look at this particular picture, I'll move up a little bit here. You can see that there is coal burning, and it basically is going to cause the water to boil. And when that happens, steam is produced. And that steam is going to have enough energy to turn the mechanism within the turbine. And that movement within a coil of wire is what is producing electricity here. There are actually phone chargers that you can plug up if you're going camping or something like that, or you're not going to be around an electrical current. And you can actually turn this crank. You connect it to your phone. As you can see the wire down here in the bottom, you connect that crank to your phone and you are going to create enough energy for your phone to work for a period of time. This is what they call a shake flashlight. And so you can see the coil of wire here. There is a magnet right here. I actually have one of these in the classroom. If I could show that to you, I would. But when you shake it, that magnet will go back and forth inside of this coil of wire. And thus it causes this light bulb to turn on. They have emergency radios. I also have one of those that you can actually use in the event that you don't have electricity. You turn the crank and it can produce light. It can produce the radio sound, so you can listen to emergency personnel if they need to try to get a hold of people in the middle of a hurricane or a tornado after the electricity has went out. So you have some information on your notes that you need to write down, and you should have three examples. Basically, the use of renewable energy sources, or unrenewable. In this case, burning coal is an non-renewable, I should say, energy source that produces electricity. Emergency radios, we use that crank to produce energy, just like we would use the crank here, and the shake flashlight. So please make sure you're writing all three of these down and what's after each one of them. So everything that I just uncovered here should be written on your notes. You leave anything off, you're going to lose some points. So please make sure you're doing that. We're going to look at how water actually generates electricity. So when we look at the water in this case, that's pretty much what we are going to look at around here. Where do we get most of our electricity from is from hydroelectric power. There is not anything on your notes that has this on it, so this is just more informational for this particular slide. But the TVA, the Tennessee Valley Authority, is where we buy our electricity from. So when your parents pay the power bill, that's what they're paying for, the generation of electricity by using primarily water. Because there are so many rivers in this region, and because there are so many rivers, they have built dams back in the 1930s. And when those occurred, a lot of areas were flooded, but it also generated a tremendous amount of electricity for that period of time. So what we're going to do is we're going to learn how electromagnetic induction allows us to produce electricity using different forms of, in this case, renewable resources. We're going to look at water and we're going to look at wind. So you're going to have those two things. So I want you to watch this video right now.
Force of falling water. Water is held behind a dam, forming an artificial lake or reservoir. When electricity is needed, Some of the water in the reservoir is released through a water intake in the dam. Gravity causes the water to fall through a pipe inside the dam called a penstock. The falling water spins a turbine, a type of water wheel that converts the water's energy into mechanical power, which is located at the end of the penstock. When the turbine spins, it turns a metal shaft which goes up to an electrical generator. As the shaft turns, it causes the generator to rotate, producing electricity. After flowing through the penstock and across the turbine, the water continues into the river on the other side of the dam. Hydroelectric power is a renewable source of energy. It's also one of the most cost-reliable forms of electric production.
So, what this basically did was explain how that movement is going to allow the generation of electricity to take place. So here you have this animation that basically is similar to the video that we just watched. Underneath how water generates electricity, I want you to add this information on your notes because this is exactly how it happens. It transfers mechanical energy, which is moving energy or kinetic energy. And in this case, it's movement due to the water. So when the water moves from behind this dam, of course, we've trapped it, and we open up this intake valve, it will flow downwards into this region. This is where it will turn. The water causes movement to turn the turbine. And when that turbine turns, as you can see, this little lightning bolt here, it generates electricity. So if some of you may go fishing along with South Holston, they'll say that, hey, they're generating during these particular hours. What that means is the water level is going to increase down the river. It's going to flow a lot faster because they are generating electricity during those particular hours of the day. So I want you to fill in. You have some yellow boxes or they're not yellow, but you have some boxes underneath the picture, and you're going to fill this in. The very first step here is that water behind a dam, it gets stored up. So we store moving water. Basically, that is your potential energy. Sort of goes back to sixth grade when you guys talked about those different forms of energy and how those transfers occurred. After it gets stored behind the dam, if they're going to try to produce electricity, you're going to open that intake valve. Water's going to flow through the pipes. And those pipes here, this penstock, is going to allow that water to be transferred to this turbine. Okay, so that's what you're going to put in the second box. And then that is now moving water. So there's your movement. That movement causes the turbine to turn. That has a coil of a wire within it. That movement within it is going to generate and induce electricity to be produced. That's why you see that lightning bolt. So that gets transferred from a kinetic form of energy into electrical energy. And now the power lines are going to move that electrical energy out to your house. So that's how we pretty much get our electricity around this region. There are some other forms in the Southeast that doesn't rely on water, but because we have such plentiful resources of rivers in the Southeast, that's primarily what they use. Okay. Next one we're going to look at is wind energy. Okay. So how wind generates electricity is basically the same thing, except you're going to see something different in parentheses. So I want you to write this down underneath the heading that says how wind generates electricity. You're going to write transfer of mechanical energy, and in parentheses, this time it's due to the movement of wind. So the wind is going to cause the turbine to turn, not the water. This is a windmill type thing or a wind turbine. So we're going to watch this video to sort of see how this works. It's very similar, except you don't have water.
On top of each turbine is a box known as a nacelle. Attached to the nacelle are three propeller-like blades that connect to a rotor. Also on the nacelle is an anemometer to measure wind speed and direction. The wind direction rotates the nacelle to face into the wind. The energy in the wind, called kinetic energy, turns the turbine blades around the rotor, creating mechanical energy. The rotor connects to the main shaft, which turns inside the generator housing. Here, a magnetic rotor spins inside loops of copper wire. This causes electrons inside the copper to flow, creating electrical energy, what we call electricity in our daily lives. For this wind turbine, a step-up transformer inside the nacelle increases the electrical generation from 690 volts to 3,400 volts. The electricity generated then travels down large cables from the nacelle through the tower and into underground cables. The cables take the electricity generated from all the wind turbines to a substation. Here, a step-up transformer again increases the electrical output. A transmission line connects the electricity output at the substation to the electrical grid serving communities throughout the region.
Okay. So, not very different. There's still movement involved. Kinetic energy is transferred into that. Kinetic energy is the movement, is transferred into a electrical energy. So here's basically a picture that we're going to follow along. Here's step 1, 2, 3, and 4 to get to the point where we could use this wind electricity, this wind generator to produce electricity. Okay. So the aerodynamic aspect of it is the wind itself. Okay. The wind is moving. And that kinetic energy of that wind is going to turn the blades of the turbine. Okay. So right here, you're going to have that wind turning the blades. Those blades of the turbine is connected to this region right here, and that rotor. And so that rotor is then going to turn. When that turns, that causes movement of a wire coil that is within all this. Okay, so there is a wire coil, and that is where your mechanical energy is taking place. So kinetic energy is movement, but it can be turned into a mechanical form of moving because now we're talking about it inside of a machine, and this machine is this wind turbine. So we have a mechanical aspect to it. We have gearboxes. Those gearboxes are turning these generators, and that's where you're going to get that mechanical energy to then be transferred into another form of energy. That's where your electrical generation of electricity is coming from within that generator. It then sends it out to the utility grid, to the power lines, and transformers will change the strength of it to where it's really, really high amounts of electricity and the really big power lines. But by the time it gets down to your house, they're called step-down transformers, and it reduces the amount. So every house gets a little bit and not the full-blown amount. Otherwise, your whole house would pretty much be blown out, your TVs, your radios, whatever it is that you have within it. So once again, the reason that I went into these is to try to explain to us how we get electricity in the first place. It is through electromagnetic induction. It is through movement within, either caused by water, wind, steam, coal burning, whatever it could be. Okay. But it is going to be a movement of an object within a wire coil, okay? And that mechanical energy allows into the induction of electricity to take place. You can simply do it by shaking that flashlight like we looked at, by cranking a crank radio. It can be as simple as that or as complicated as this. So if some of this was a little bit complicated for you, you can look on pages 158 and 159 in your textbook. It goes into some more details and maybe some things that I didn't necessarily go over, but may make more sense to you if you read through it. So these are just all your different forms of renewable resources: solar, wind, biomass, geothermal, hydroelectric. I don't need you to know the details for each one, but just in general, how we have all that to take place. So when you look at these particular pictures here, you're looking at, once again, many more examples of electromagnetic induction. The alternator within your car is allowing that production, so your motor will turn. You've got just generation of electricity, and any of these devices pretty much allows the world to turn as far as automobiles, planes, and that kind of thing. Okay. And along with us just wanting to power up, watch our TVs, power up our phones, whatever it may be, you depend on electromagnetic induction. And that is very different. That is the complete opposite of making an electromagnet. So it's really important that you know those differences.